Okay, switching order is not always necessary, but I want to go through what the region looks like. And the lower limit is going to be y equals the arctangent. That's the lower limit. And the upper limit is y equals pi over 4. And this is relatively easy to graph out. I mean, the arctangent looks sort of like this over here. And then pi over 4 would look like, well, this asymptotic here, pi over 2. So pi over 4 is over here somewhere, all right? So, this is y equals the arctangent of x. And this line over here is y equals the pi over 4. All right, I still don't have a region yet. What else do I know about it? It starts at x equals 0. I'm working my way out, lower limit 0, and it goes up to 1. What does that look like? Well, 1's going to be right here. And why is that? The tangent of pi over 4 is 1. So this is the region we're talking about, all right? I want to look at a better picture, and a better picture is over here, all right? This is the curve y equals the arctangent. This is the line y equals pi over 4. This is the line over here, x equals 0. And this is the line here, x equals 1. Right, and this is the region over here. All right, so let's go back to the integration and see if we can perform the integration as written. So again, by eraser, I kind of know the region. If we have to go back to it, we will. But I'm going to look at it, and I want to see if I can integrate as written. If I can, I got to start thinking about it. All right, so what do you get? I'm going to go to the inside first, and I'll tell you what I'm doing. I'm doing this over here. Can I do that? I can. The antiderivative of cosine is sine of y. And we're going from, y equals the arctangent of x, and the upper limit is going to be pi over 4. So I think I can do that, and I'll write this down for you. This is going to equal, the sine of pi over 4 is 1 over root 2, and then I get minus the sine of the arctangent of x. I'm going to try to visualize that for you, and the way I do it, I kind of visualize there's an angle here and a right triangle over here, where this is the angle. What do I know about that angle? Whatever that angle is, the ratio is going to be x over 1. What's this thing over here? It's the root, right? Pythagorean theorem, x squared plus 1. So the sine of that, let me write that down for you, 1 over root 2 minus, what do you get there? You're going to get opposite, which is x over the square root x squared plus 1. Now, granted, this could turn out to be a nightmare, just like the last one I had SI. Maybe this is a nightmare too. Maybe that's the reverse order. Who knows? Let me get my eraser out. I think I'm satisfied with my result over here. And I'll write it down for you now. So what do we get over here? We just did the integration. This is 0 to 1. 1 over root 2. We just did that. Minus x over the root of x squared plus 1 dx, all right? So we did a little groundwork, we got that. I want to see if that's written in the key, and I clearly see that in the key, by the way. Right, there are steps missing, and we'll go through that. So let's do the first thing, which is the first antiderivative, which is 1 over root 2. X, limit's going to be from 0 to 1. Relatively simple. The next one's going to be minus. It's going to be 0 to 1, x, the square root of x squared plus 1, the root of it, dx. I'm going to use a u substitution to do that. I'm going to say x squared plus 1, and so du would be 2x dx. And I'm trying to figure that guy out, by the way. Now, as I do that, I'm going to do one thing at a time, by the way. I'm going to do this right away. I don't want to forget that guy. And what would that give me? Let's see. That would give me 1 over root 2 minus 0, which is 1 over root 2. I'll do the second integration. I'll write it down for you. When x is 0, u would be 1. And when x is 1, u would be 2. All right, then I get, u to the minus 1/2. And x dx is going to be a half of a du. All right, I'm going to keep working through this. We'll look at the key in a moment. 1 over root 2 minus 1/2. Increase the exponent by 1, so that's going to be u to the 1/2. Divide by half or multiply by 2. Well, these 2's cancel off. Limits of integration there are going to be from 1 to 2. So we write that down, 1 over root 2. Again, we're trying to evaluate this over here. And that's going to be what? Minus root 2. And minus and minus would be plus the root of 1, which is just simply 1. All right, so let's kind of simplify this thing. I'm going to write common down by root 2. You would get 1 minus 2. And then you get plus root 2. That's going to be root 2 minus 1 over root 2. Put a box in that. Going to commit that answer. Yeah, mistakes happen. And I want to point out, I'm looking at their answer and my answer. I'm going to say they're equivalent. So what's that? Root 2 of root 2 is 1, and you get minus 1 over root 2, right? Relatively simple, all right? Let's see if that's, that's the case. Relatively simple problem. And we didn't need to look at the region, but I can't have to look at the region in case we got to switch the limits around, the order of integration, by the way. And if that doesn't work, we got to go to something even more complicated. Thank you.